Hi, everyone. My name is Dave Fadley. I'm a member of the programs committee here in the chapter, and I want to welcome everyone tonight for attending tonight's virtual lecture. So feel free to type questions into the chat window during the presentation. I'll leave it to Sean, our speaker, to decide if they care to answer questions during the talk. Otherwise, we'll get to questions at the end of the talk. And tonight's presentation is the Incose Digital Engineering Information Exchange Working Group. Tonight, we're honored to have Sean McGervey with us. Sean is a principal systems engineer at Strategic Systems, Inc., where he developed a course in MBSE for digital engineering and provides MBSE consulting services for various customers. Previously, Sean served as the director of MBSE services and model-based enterprise for North America at Dassault Systems, where he led a team of expert MBSE consultants and trainers. Prior to Dassault Systems, Sean was a systems engineer and MBSE instructor at Johns Hopkins University Applied Physics Lab. He was the U.S. Navy's architecture lead on a major defense acquisition program and contributed to efforts supporting digital engineering transformation of APL sponsors. Sean is the 2023 president-elect of the Incose Chesapeake chapter and is also chairperson emeritus of the Incose Digital Engineering Information Exchange Working Group. Sean is an OMG certified systems modeling professional at the Model Builder Advanced level. So with that introduction, I will now turn the virtual platform over to Sean.
All right. So thank you, Dave, for that great introduction. I appreciate it. Really excited to be here and present to you guys on this. It's been my distinct pleasure to be involved with the DEIXWG for several years since its initial inception, when Philomena Zimmerman and OSD kind of met with a bunch of folks at Incose and NDIA back in 2017. And so it's come a long way since then, and really excited to be able to talk to you guys about this tonight. As far as questions, feel free to stop me anytime you want. If you have a question, you can also put it in the chat if you don't want to stop me mid-cadence, or if you want to, if you're shy, just want to put that question in the chat, totally fine. I'm an adjunct professor at Johns Hopkins in their graduate SE program. And I always tell the students, if you don't stop me, I will just go on and on and on. So feel free to chime in. All right. So with that said, probably the first question. Oops. Let's see. There we go. Probably the first question I always get asked is, what is the DEIXWG, right? So the DEIXWG is a collaboration between actually not only Incose, but also the NDIA and also DoD's OUSE R&E. Like I mentioned, it was kind of the brainchild of can folks see my screen now?
Yes, we can see it.
Yes.
Awesome. Awesome. All right. Apologies for that. So if folks are familiar with the digital engineering strategy from DoD, the DES basically outlined some high-level goals that DoD was pursuing in order to be able to, in order to be able to push this digital engineering paradigm. And from that, the various services have created their own take on the strategy, kind of tailoring it for their specific branch. At a high level, these are the goals. And honestly, I think the toughest one is number 5, transforming the culture and workforce. For my time at Dassault and even before that at APL, it was always the biggest challenge, regardless of how many tools and languages and frameworks you throw at the problem. Training and adoption by the workforce, preparing folks for a digital engineering future is always the toughest one. So on that note, however, the DEIXWG kind of supports all of these, but is really about the first one, which is in order to, and also the fourth one, in order to provide the sort of the basis for the digital exchange. Now, the next question after what is a DEIXWG is usually, why do we even need a DEIXWG? And literally, we've been asked that question before when we were on a panel with Phil Zimmerman at the Incose IS 2 years ago. Somebody asked astutely, hey, why do we need to do a DEIXWG? We just, pack up our Cameo models or our CAD models or whatever, and we just deliver those things, there, digital engineering, no big deal. Um, Part of the issue is that this is a challenge of data science. And so it's sort of a similar thing in traditional modeling in sim, right? You might have a bunch of federated simulations and models, and there's hidden assumptions that all those models have, because models by definition are not a perfect representation of the system, right? If they were, they would just be the system. But they're abstracted in some way, and in some ways they are tailored towards a particular intended use. And so as you start to federate these models together, you run into sometimes an impedance mismatch, if you will, between the different kinds of models. And that's where we run into these issues. Everybody approaches the exchange issue from their own perspective and their own point of view, of course. And so when we try then to put those things together and exchange them with somebody else, they pull it into their digital engineering ecosystem. They try to make use of those models, even if they have the same exact digital engineering ecosystem. They may run into issues in just the semantics of their assumptions for how those things are connected. But from purely just a mechanical kind of standpoint, even just syntactically, it's important to figure out how we relate those elements together. And a lot of the problem, and what I used to say when I was chair of the DEIXWG was, our issue is more than coming up with some new lexicon or standards or terms. It's all of that, but it's also this notion that we need to have almost a meta model of meta models, right? So in other words, in SysML, there are concepts like blocks and ports and activities. We don't have a one-to-one match of those concepts in a CAD tool like a PTC Creo or something like Team Center, or for a PLM suite or whatever it is, right? There isn't a one-to-one match. And so trying to align all those models can be very difficult. As a brief anecdote, I'll just say, when I was at APL, I was working on an IRAD where we were trying to combine a CAD model with a SysML model and then render it in a three-dimensional view. So you could visualize your SysML data overlaid over your three-dimensional geometry. It's pretty cool, worked really well. But in the early days, I created a SysML model of a quadcopter to use as an example for my IRAD team to work on. And they complained that the SysML model was not suitable because it didn't match the CAD model of a quadcopter drone that they downloaded online. So in other words, the quadcopter drone had, down to the washers and bolts and all that good stuff on the different portions of the assembly for the propulsion. And I only took it down to the propulsion assembly. And when they said, where's all the nuts and bolts in your SysML model? I kind of just said, look, I'm a systems engineer. I don't think you want me going down to the level of, picking out the thread count on the individual bolts or what kind of washer material you're using or any of that stuff, right? We'll leave that for the mechanical engineers and the detailed designers and electrical engineers and so forth. But the systems engineer needs to be concerned, of course, with the broad system performance. So I need to know how the details of the CAD geometry or the engineering analysis models or those kinds of things affect things at the system level. But even in that brief anecdote, we could see the issues of digital engineering information exchange coming into play. How are we able to relate those products across different meta models essentially within our digital engineering ecosystem? So part of it, like I said, is a data science challenge, and things like concepts like a car. If I say the word car to you, you'll all have an image instantly in your mind of what a car looks like. And we probably all have the same image, but the devil, as they say, is in the details, right? So if I think of, say, the mass of the car, so conceptually I say, well, I need to worry about the car's mass. What does that mean to you, right?
when I said mass, were you thinking of just the mass of the car itself that rolled off the assembly line? Or does that include the mass of the tires, the fuel, hydraulic fluids, cargo, the people in the car? Does it include those things? Now, you might say, no, those things aren't parts of the car, and that's totally valid. But if I'm working on creating some sort of a simulation of traffic conditions and road handling and this and that, then those things might be, things that I might include as what I define as the car, because I'm concerned about, the actual road dynamics and performance of the vehicle under wet conditions and that kind of thing. So, seems like a simple assumption one way or the other, but those kinds of things really come back to bite you. And from a modeling and sim perspective, and when I was at Northrop Grumman, that was the area that I worked in, was creating constructive simulation for Northrop. We sort of instinctively knew that we had to buy down those assumptions, right? Or document them well and make sure that everybody was on board. Even things like, how many digits in pi when you're doing your mathematical calculations, right? Because just a few digits off on one model versus another one, and now you have a mismatch between the two. And that's sort of what is shown here graphically, right? I may take that concept of a car and its property of a mass, and I might try to represent it in SysML as just a block with a value property for the mass. I might try to model it as an assembly or a part or something in a CAD tool, and I'll call it car and I'll give it a mass. But do all those models make the same assumptions? So where does the digital viewpoint model come in then? So the DVM is one of the major products that the digital information, or that the digital engineering information exchange working group has put together to help deal with this issue. And essentially what it is it's a conceptual, implementation agnostic, in other words, platform independent reference framework. It's used to basically describe and specify the kinds of digital artifacts and sources of digital information that you have in your ecosystem, and how those elements of information relate to one another. In other words, that example I gave earlier, of a SysML block, trying to relate that to a part in a CAD model. Those kinds of things could be described using concepts from the DVM in an implementation agnostic manner, and then extended and then implemented in a more concrete manner for a particular digital engineering ecosystem, for in other words, your collection of tools and environments that you use to build your digital threads. So it's really a high level framework. It has an ontology underpinning it. Don't be afraid of that. Sometimes the dreaded O word can be a turn off to folks. We are not creating yet another ontology and trying to use that as a formal basis for anything. The ontology itself is used more just as the underpinning of the meta model of the framework itself. So think of like unified architecture framework, right? Where you would use UAF to describe an enterprise architecture, and UAF as a framework itself has an ontology, the ideas ontology, and it has a meta model for how that ontology is then turned into representative element types in UAF. And then you make use of those elements in UAF. You make use of the meta modeling principles in order to develop your model of your enterprise architecture. It's the same idea with the DVM. The DVM is a framework just like UAF, and it would have its own ontology, its own lexicon of standard terms that we're actually working with ISO right now to standardize. And then you would use that reference framework, the DVM, to describe the kinds of artifacts that you're connecting together, and semantically how they should relate to one another, how those artifacts will be curated, managed. All of that would potentially be included in the DVM. So looking at it another way, the idea is essentially this one, which is, how do we take a collection of digital artifacts? So I've used that term a couple times now without defining it. So, bad professor, right? But the idea is you have a bunch of digital artifacts, and it could be a finite element model, a CAD model, requirements model, whatever it is. And how do I take the elements from those models, relate them to one another in some sort of meaningful way semantically, not just syntactically, but get the meanings behind those terms to be aligned and compatible with one another, and then present it in a digital view. And that could be a 3D, visualization like we see on the right. It could be an output sent to a spreadsheet. It could be, the digital quote unquote view could actually be, something that you listen to, for example. So, the analogy I gave at one point was, if we think of a digital artifact as an email, right? I could either read the email visually on screen as a collection of words, or I could have something read the email to me. And it's a different presentation of the same underlying content, right? And that's kind of the idea here. How do I take the content, the digital information contained in these digital artifacts, use the DVM as a lens that connects all those pieces together, and then generate a view of that information? And again, I use the term view and viewpoint very much in the spirit of the architecture standard 42010, right? 4210, because that is exactly how we're using the term here. The idea that, again, let's take UAF as an example. In Unified Architecture Framework, you might have operational views. You might also have resource views. And the idea is that within those given viewpoints, you're seeing a particular aspect of your enterprise architecture through the lens of those particular views within that given viewpoint. And that's the same idea here. You might have a collection of digital views that have to do with a particular point of view that you're looking at these digital artifacts through in order to do the kinds of specifications or analysis or whatever it is you're doing throughout the life cycle of your project. So again, this way. So again, the DVM, I'll kind of talk about the high level overview of it. You're kind of seeing it in SysML version here. It is an implementation agnostic framework. Honestly, we just used SysML because those were the tools we had available. We had thought about using something like Protege, for example, to actually create a ontology and use that. And we thought, maybe we should just use something like Cameo Concept Modeler, where we can just model the concepts. And then if we still want to connect it to an ontology, we can export it that way. At the end of the day, we just said, look, we're just going to use SysML constructs because we're all familiar with it. We have access to tools like Cameo. But again, the idea is not how it's constructed in a model form here in the DVM per se. It's more the concepts and the relationships that are represented by the DVM. And so what we're seeing here are the four major areas of the DVM. You have the digital views, which I mentioned earlier. Those digital views are constructed using information pulled from digital artifacts. Those digital artifacts, whether it's a SysML model or a CAD model or whatever, are produced by process steps, by process concepts, whether it's system development or you're doing an analysis and you generate a report or whatever it is. And those processes are performed by stakeholders or are driven in some way by stakeholders. And those stakeholders are the acquirers and the suppliers of the exchange. And those are the terms that we came up to use for those kinds of things on either end of the exchange point. Now, acquire and supplier, that doesn't necessarily mean a big ACAT 1D, Department of Defense program, with some formal deliverable, and here's the technical data package that the contractors provided to the government. It could mean that, but it doesn't have to. Stakeholders in this case, the acquirers and suppliers, could be, folks from different teams or different units within the same company. It's really just a way of thinking of the provider and require sort of relationship if we think about those terms from like something like SysML or UML. Here's an expanded view of that DVM, those 4 areas. So digital view concepts in the upper left. We can see how it breaks down into not only your digital views, but when those digital views might be used, different assessment points. And those assessment points would happen throughout the life cycle phase. Now, again, assessment point, and again, we struggled over a lot of these terms. So if you guys have ideas, I very much am sincere in saying, feel free to join the Incose DEIXWG, contact me for information and join in the fun. But yeah, it's been a long road for some of these concepts. Assessment point is one of them. We had thought initially, again, in our heads, we had the idea of a design review, right? And we thought, well, an assessment point might be, a CDR or PDR. But again, kind of like what I said with the acquirer and supplier concepts, that doesn't have to be, a formal assessment or a gate review, like a preliminary design review or a concept or a critical design review, something like that. It could be just, hey, we've been making steady progress on this set of products. Let's do an assessment, or hey, I have to do an analysis, some interim analysis, or prepare for a technical meeting or whatever it is, right? It could also be a formal gate review, but we tried to keep the concept broad. And the idea is then you can extend these concepts for your own specific needs. So those digital views, the assessment points, the life cycle phases we see in the upper left, all of those then relate to the digital artifacts that we see in the lower left-hand side. And those digital artifacts could be a digital system model, like a Cameo model, or something in a slate or whatever the tool of choice is. That digital system model, if it's a SysML model, it could have model elements, which might be blocks or activities and so forth. That's just one of the kinds of digital artifacts we could have, though. Digital artifact could be an Excel spreadsheet, or it could be a relational database. Doesn't matter. Could be anything. Those digital artifacts would be, perhaps proclaimed as an authoritative source of truth. They might be contained in a repository, which is accessed by some application. So again, if we're talking about a digital system model in SysML, that might be the authoritative source of truth for our system design, contained in a Teamwork Cloud repository, accessed by Cameo System Modeler. That tool, that application would be used as part of a work activity. And so that takes us to our process concepts in the lower right-hand side. And so we've got this dichotomy we see left and right between the products or outputs produced and the activities or analyses or queries that generate those products. And those things are going to be managed through governance processes, one of which might be curation. So, the concept of digital curation is something that folks in Incose have mentioned for a couple of years now, coined by Donna Rhodes at MIT. And I really like that term a lot, right? It's sort of like saying, I if I have a piece of art in a museum, I'm not just going to, just randomly stick it on a shelf in some room and tell people to come take a look, right? I'm going to curate that art. I'm going to have the right lighting. I'm going to have it roped off appropriately to prevent people from touching it. I'm going to have a placard next to it that explains about the artist and the work of art. That's curation, right? And that's how I kind of think of these digital artifacts as well. You don't want to just hand somebody your Cameo model or hand them your simulation. You want to be able to tell them, hey, for this simulation, this is the intended performance envelope for which its results are valid. Don't use it to try to analyze this phenomenon or that phenomenon, right? Due to its level of scope or fidelity or whatever. This is the appropriate use case for this model. That same sort of idea holds true for a SysML model or a CAD model or whatever. There are some things, again, that the models are good for and some things that they're not because that's not their intended use. And that again, gets to that idea that models by definition are going to be imperfect, right? So curating them is important. Having that governance practice around them is important. And that even gets to other work activities as well, like configuration control, or configuration management, and then, more than just version control, but by understanding and being able to analyze, what the impact is on a design due to a configuration change or whatever it might be. Now, those activities have to be performed by somebody, and that someone is a stakeholder. And those stakeholders will have a certain perspective, right? So I might be a supplier. Perhaps I work for a contractor, a prime contractor that is supplying an ICD, interface control document to an acquirer. Maybe it's a DoD, acquisition authority. And that ICD that I'm supplying, maybe I'm a electrical engineer, and this is the electrical ICD that I'm going to be providing to the acquirer. So my discipline is electrical engineering. My perspective is interface control, and I am the supplier in that exchange. And what we're exchanging via these various work activities and work products might be a collection of digital artifacts that then are provided and consumed through a set of digital views. And the idea is that we could use this framework then to basically, describe the required sets of artifacts, the required information that they have to have, the level of quality that they need to have, and how we intend to view and make use of those artifacts, given where the authoritative data is coming from and how it's been curated. So I knew there was a whole lot of things I just went through there. Hopefully that made sense. I'm going to go through all these in a little bit more detail, and then we'll see some examples of what I mean by digital views, digital artifacts, and how we consume that. All right, so stakeholder concepts. Again, just the stakeholders involved in the exchange of the digital information. All the stakeholders are going to practice some discipline, whether that's electrical systems, mechanical, whatever the discipline might be, and they'll have a certain perspective. So somebody might be a computer scientist, and the perspective is cyber security or information assurance. They might be working as the supplier or the acquirer in that exchange. Are they providing a set of digital artifacts or a digital view of those digital artifacts, or are they the ones consuming that information through that digital artifact? Digital views, again, these are your means of conveying the information, your means of viewing certain key information and the relationships. Again, I like to think of things like UAF, right? If I look at a resource process view in UAF, then I'm interested in understanding the various functions that systems and personnel and other things perform in order to achieve some sort of goal or some sort of use case. Same idea here. What's the purpose of the intent of the digital view? And in order to provide that purpose, what does the digital view have to draw on from the digital artifacts in terms of information? And how do we need to relate those pieces of information together when we kind of realize that they may come from different models with different underlying meta models that govern their own semantics and syntax? Those digital artifacts, again, could be a digital system model, as we show an example there, but it doesn't have to be, right? Digital artifact could be, again, like a spreadsheet. It could be a relational database. It could be a CAD model. Could be any number of things. We have digital system model, listed out here just because that tends to be, a pretty popular one in digital engineering circles. But remember, digital engineering is engineering, right? It's not just MBSE. MBSE is just systems engineering, and systems engineering is just one discipline within engineering. So when we look at digital engineering, there's any number of types of digital artifacts beyond digital system models come into play, and we need to be able to relate those things together and exchange them with other folks who may or may not have the same digital engineering ecosystem that we have. And again, those artifacts are produced by process concepts. So we might have work activities and work products at a high level, right there in the middle of the diagram. So various work activities may produce those products, whether it's, developing a model, developing a simulation, whatever it might be. There may be analyses. So, for example, on previous programs, we would get model-based artifacts from contractors in SysML, in Cameo, and we would create custom diagrams, traceability matrices, and tables inside of Cameo using their model in order to be able to analyze it. Oh, oh, sorry. I think somebody's got an open mic.
Then what I'm shouting, what is, then you will want to comment.
Hi, is there a question? Sorry. Oh, nope. Okay.
I muted him out, sir.
Okay,
If you want
thank
to
you.
come back in, please raise your hand.
All right. No worries. All right. So that's the idea behind the process concepts. And you can kind of see the breakdown here where we have a, inheritance relationship, for example, where we say, hey, given work activity, one type of work activity may be an analysis. And one type of analysis we might perform is a query. So think like if you guys are familiar with Cameo, the query might be meta chaining. That might be one type of analysis we could perform. We could also just do traceability gap analysis, for every requirement. We want to make sure that that functional requirement, if it is a functional requirement, is satisfied by a function. That might be a nice type of analysis we might want to perform. And in all cases, it's going to generate some sort of an output, whether that analysis leads to a table or a matrix or whatever it might be. All right. And again, the DVM is intended to be extended, right? So we purposely did not want to try to, put every type of domain or specialty or interest or whatever it might be into the DVM, right? We kind of took the UAF approach, or if you will, we took the SysML approach to keep things generic, but sort of encourage people to extend them for their particular needs. So UAF is going to have very high level concepts in its framework for modeling your enterprise architecture. And then it's up to you as a systems engineer or systems architect or enterprise architect, I should say, to extend UAF for your particular needs or your domain or whatever it might be. Same with SysML, right? It wasn't until very recently that they even included the ability to have a safety and reliability profile in SysML. Because it kind of realized, okay, for systems engineering, that's probably a good extension, profile to put into the language. But for the most part, SysML is very generic by design, by nature, in order to not preclude a particular methodology or way of doing things. And that's the same with our approach for our DVM. For the DVM, we provide the high level concepts that you see highlighted in yellow. And then you can extend it for your particular needs. In this case, to create a matrix to assess functional allocation traceability. So we might say, hey, the particular digital view in this case, it's not a digital system model diagram, like a block definition diagram, let's say. It's a traceability matrix. So if we're doing SysML and Cameo, maybe it's a dependency matrix, right? And that traceability matrix, it could be just a generic dependency matrix, but we're going to create a specialized one called a functional allocation matrix that looks at the allocation of, activities or actions to blocks or to, in this case, assets. So, still keeping things kind of high level, we're saying this functional allocation matrix, it's looking at actions and the assets that perform those actions as two kinds of model entities. And then those model entities have a relationship between them, which is another type of model element. And this relationship is allocation. So we want to see how those actions have been allocated to the asset that's responsible for performing them. So that's a very simple example. And I'm sure you guys are all familiar with, like if you're familiar with SysML, I'm sure you're familiar with how SysML, uses an allocation relationship, but that's the same kind of idea here. And that may seem like that's overkill to extend that for this case, using the DVM just to express, hey, I want to see my activities allocated to my, my blocks or whatever it is. But, believe it or not, even within SysML, that assumption does not always come out the way you think it will come out. So in my JHE class, I've had tons of students who've, tried to, show me the allocation of actions to blocks versus activities to blocks. And that's two very different things. And one is legal in SysML and one is not. But the tool will let you if you try to force it to do that. And so it's good to be able to be precise about what it is you're looking for, what it is you're trying to consume, and what the intent of that particular view is. All right. So other DBM related products, one of the things we started to realize too is that, the first thing we knew is that we don't know, right? And as the Digital Engineering Information Exchange Working Group leadership team, we're like, we're just a collection of people who have some ideas about, what we should try to capture and specify in terms of these artifacts, but we need to hear what the community's pain points are. So early on, we did a number of digital engineering information exchange challenges, and we had a number of collaborative workshops, both at the International Symposium and at the Incose IW as well, particularly at the IW where it's really well suited for that. And at the international workshops, we had sessions where we sat people down and said, all right, let's come up with a use case. Let's say we're almost at the stage of a critical design review on an ACAT 1 program, and we need to, using our beloved 15288 handbook, we need to provide certain kinds of deliverables and products to do certain life cycle type analyses or work activities or whatever. What are the challenges involved in that? And we asked the community, where have you run into challenges with this, whether it's delivering as a contractor to government or between two different partners on a contract or whatever it is. Where have you seen pain points or issues with that? And how can we, describe the issues in a better way so that we understand how to relate those kinds of artifacts, and then can turn to a tool vendor or whomever and say, I need to relate this kind of model to this kind of model using these kinds of relationships. How do I do that? Do I, go get a PLM tool and connect them all up? But well, how do I connect them? What's the right way to connect them? Do I connect a block to a part in a Creo model? Again, using my example from earlier. So those are some of the user stories that we looked at. And guy on the team, Ken Zhang, really sharp guy. He's now the lead for the DVM work in the DEIXWG, and he put together a set of user stories, some examples listed here, so it gives you an idea of the needs for the information exchange. And it's the typical kinds of usual suspects on a program, the kinds of activities you would do, and the kinds of outputs you might generate or analyze or whatever it is throughout your life cycle. This is a spreadsheet that he put together, at least a snippet of it. The spreadsheet is huge. This is just a very small portion of it. And it's since evolved actually from the time that this screenshot was taken a couple of years ago, but the idea still remains the same. You might have stakeholders and you might have various perspectives for those stakeholders. So again, if I'm, let's say, the acquirer, maybe I'm concerned about design compliance. I want to make sure that the given design that's being proposed by the supplier is meeting the appropriate standards and following certain procedures or process or whatever it is. In this case, my particular need from my perspective of design compliance is I need to review the T&E strategy for the program. And specifically, my rationale for doing that is that I need to ensure that the system's at a certain level of test readiness, right? That it's ready to go to, a TRR, or it's achieved a certain, technology readiness level or whatever it might be in order to proceed to that next phase of development. So how am I going to do that, right? I don't want the contractor, to back up the big dump truck full of paper to me and just say, here's all my spreadsheets, here's all my Word documents, here's a bunch of models that aren't connected, here's some other stuff in a database, and it's all there. You just have to, connect the dots, but, enjoy, right? That's not what I want to have happen, right? What I want to be able to do is say, do you have maybe I don't know, we'll call it a test configuration and procedures view that I could look at. Maybe it's a 3D view or a dashboard or a report that's generated or something that I could look at that has the dots connected for me, and that I can trust that the dots are connected in some sort of semantically meaningful way. And that way I can look at that view and be able to, analyze or look at the things that I need to see in order to ensure that the system is reached a certain level of readiness. So here's what that digital view might look like, let's say. So this digital view, might have the certain artifacts we see on the left, like traceability requirements. Something somewhere has to, have, the authoritative source of the requirements traceability, that mapping between our requirements and the things that are going to be used to verify those requirements, the test cases or analyses or whatever it is. We might need digital artifacts for the test configuration or the set of test cases and procedures, et cetera, right? And those digital artifacts, they may be a relational, database element of some kind. It could be elements from a SysML model. It could be a Word document. Who knows where that information is coming from. And those things have to be put together now at a certain level of maturity and detail appropriate for the phase, which is CDR, because, our test readiness report, or even better, let's use ICDs, right? Our interface control document, when we're in conceptual design or we're in functional, design, we're in, an SFR level of maturity, it's going to look very different than when we're at a CDR level of maturity, because of the fact that there's many things that are still TBD as of the SFR, where the CDR, we're down to, no kidding, this is the wiring harness, and here's the signals going over various, wires and whatnot, and the kinds of discretes that are being exchanged and whatever. All right. And the idea here is we want this to help support acquisition, right? Right now, we have plenty of specifications for deliverables. Statements of work have all sorts of, line items for procedurals and different things that have to be delivered. We have DIDs, right? So if you're interested in an ICD or a technical data package or a SSS or whatever it is in DoD terms, the DoD has the DIDs that explain the kinds of content. What they don't explain, though, is what the rules are for semantically relating those things, and they can't, right? Any more than I could say, I'm going to come up with a set of rules for the one way you should model a car. That's not possible, right? Sometimes you might have a low fidelity model of a car that's just a SysML block with a bunch of value properties. Or you might have a high fidelity SysML model of a car that gets down into the individual spark plugs or whatever. Do cars still have spark plugs? I guess they do. All the various individual components of the car at the lowest level, right? Neither model is wrong, right? Just they're used for different purposes. I would not want to use that high fidelity model of a car early in conceptual design when I'm just trying to understand the design space, right? By the same token, I would not want to be using the same conceptual model of a car when I'm at CDR and I'm trying to make some serious design choices at that level. I'd expect more fidelity, more detail, more whatever, more depth in that model, right? And it's the same with this. The DIDs will tell us the kind of content expected, but how do we go further and explain in a digital sense how these things are connected? And one of the things too, and Phil Zimmerman, she used to drill this into us all the time. She's like, digitization is not the same as digital, right? I don't want to just take the paper procedural document, let's say, and digitize it. That's not digital engineering. I want to take advantage of the fact that we now have, fancy schmancy models and computers that they run on and everything else. I want to take advantage of that new model-based environment and be able to, have those things relate together as, digital artifacts in some sort of broader ecosystem, right? I don't want to just say, here's my silo of data that used to be a paper document called a TDP or a triple S or whatever, and now magically it's a digital version of it. That's not going to cut it, right? Again, the DVM is providing us a framework to specify the exchange of these artifacts. And the important thing is that it's well-defined, it's self-consistent, and it's semantically meaningful, okay? Again, I want to be able to say, hey, if we were using, let's use modeling and simulation, right? If I were building a radar model and you were providing a tracker model, and your tracker model was expecting to get position data from me so that you could form a track, okay, let's do that, right? Well, we'd have questions, right? You and I presumably at some point would reach a point where you're going to say, hey, when you're providing position coordinates to me or position vector to me, what coordinate system are you using? Is that Earth-centered, Earth-fixed? Is that, based northeast down with respect to what coordinate origin? Is that the center of mass of the target that you got a detection on? Or with respect to your sensor's aperture? What are we talking about here? And, oh yeah, are you using metric or imperial units? Or, whatever it is, right? That's part of the nature of this. How do we think about those hidden assumptions and semantically relate that information so that I know that the position you're asking for and the position I'm providing are semantically aligned, not just syntactical. I provided you a vector of 3 floats. That's not good enough, right? I need to know the semantic meaning of what's being exchanged. Well, now that we've gotten to SysML models, models are models, right? They still have to adhere by the same rules that computational models and simulations adhere to, meaning we have to verify them, we have to validate them, and perhaps even accredit them, which is a weird thing to say. Again, from a modeling and sim perspective, my heritage at Northrop, we wouldn't even think twice about it, right? Of course, we have to do VVNA of our simulation, right? Or use a trusted, blessed simulation that the government has pointed out to us. But when we talk about SysML models, I hardly ever hear anybody talk about VVNA, or at least just V&V of a SysML model. And it's not just SysML models I'm talking about again, right? CAD models, other digital artifacts, databases, whatever it is, rather than just treating them as a bit bucket of data and then trying to just force them to federate together or integrate together, when maybe semantically there are some mismatches there that have to be addressed. This kind of talk really culminated in a set of, as I mentioned, digital engineering information exchange challenges. We had a couple of them a couple of years ago, and it was really, I like to joke, it was us crowdsourcing. We basically just turned it to the community and said, hey, how we're going to come up with a digital viewpoint model? We're going to actually ask you guys to help us with that. So what are some use cases that you have? What are some pain points that you have? Where are some areas where you've tried to do digital exchange and you've run into issues? Was the issue just purely a tool issue, like there just simply isn't a tool that connects these two models together or types of models together? Or is it more of a semantic issue, or a syntactical issue? Is it just, two models with two different meta models, two different languages? There's not really an adapter for them or whatever it is, right? So those are the kinds of things we were trying to elicit from folks. And I think we had some really great responses from the community. A number of tool vendors as well who chimed in, like Siemens and Spec Innovations, put together some challenges as well. But a lot of good discussion at the Incose International Workshop as well. And that really served to kind of help us enhance our efforts. As a quick example, so for the DEIXWG challenges, one of the things we did was provide an example submission, just again to try to elicit where people's pain points are, what kinds of things would they like to be able to do but can't, whether it's too difficult due to tooling, too difficult due to semantic interoperability between the models, whatever it is. And so I put together an example submission, and so I'll show you this. It's what I called a resiliency assessment view, right? There's no such type view like this, but that's the idea. if I had my druthers, maybe there's a resiliency assessment view that I could put into a statement of work and just tell a contractor, give me your, your RAV, in much the same way that now we would say, hey, I'd like to see your DODAF OV1 or SV1 or whatever it is, right? Maybe instead of asking for those views, I could ask for this view. And so the idea is that for this example, we're going to say we're in an assessment point where we're doing a design assessment prior to a PDR. And I want to assess, the resiliency of the system to lightning strike. In this case, it's a UAV. And I'm worried about assessing the impact to the UAV's mechanical and electrical systems due to a lightning strike while it's in operation. I'm also interested in seeing with that the resulting FMEA results, failure modes effects analysis results, as well as any compliance or non-compliance with related standards as a result of potential damage or whatever it is to the UAV. So I'm on the government team. I'm interested in looking at that, and so what do I need to what kind of information do I need provided to do that assessment to make sure that the contractor's design is sound and will gracefully fail or be resilient to the lightning strike or whatever it is, whatever the impact might be. So what's the digital information I need? What artifacts does that information come from? And then what sorts of relationships do I have to create between those artifacts? And so this digital view's intent would be to show me, in this case, an integrated view of requirements, solid geometry, material properties, all the things we see listed there. It might be in a three-dimensional view like this, where I could see information overlaid onto my three-dimensional rendering and be able to, look at it and see different areas of it light up red, maybe. When I start to turn knobs or I put in a certain stimulus, maybe certain things turn red on the display and I can hover over it and try to get an idea of, what was damaged or what things are no longer operating at full power. The problem is this is obviously going to cut across multiple kinds of artifacts, right? Not just the SysML model, but I need to be worried about the MCAD model for the 3D geometry. Finite element analysis is going to have to be done for stress analysis. If the flight characteristics change or control surfaces, what kind of stresses I can put on different things. That's probably going to involve a CFD model somewhere where I've got to worry about the fluid dynamics over the control surfaces that are imparting those stresses. Probably means I need a 6 degree of freedom flight dynamics model, not just a simple 3DOF model. But what also about the electrical connections, right? I mean, yeah, the aero guys got their hands full with the control surfaces, but what about the electrical side of things? Is there's stress on different cables or stress on different parts, or there's surges of electrical current through different wires? How does that affect things? And in turn, how does all that stuff affect the UAV's behavior during operations? Does it drop like a rock out of the sky when it gets hit by lightning? Does it shrug it off and keep going? Does it, start to degrade in capability and have to return to base or whatever it is? And then that probably also means I need a reliability model that pulls a lot of that stuff together, right? And then, of course, a requirements model, as well as standards for safety and flight safety and everything else, right? But again, and I know I keep foot stomping on this, but the big point about this is how do I semantically and meaningfully, in a semantically meaningful way, relate those various artifacts together? Because we have a whole bunch of different kinds of elements across those various models, and each of those models is governed by a different meta model. So I might have a logical port in my SysML model relating to a physical port in the same or maybe a different SysML model. That might relate to an interface design in my MCAD model or my ECAD model, which then in turn relates to, functional behaviors, interfaces, et cetera, et cetera, et cetera. All those things that are listed in that previous slide. How do I relate those things together and then be able to pull a digital thread through them in not just a tool integration sense, but in a semantically meaningful sense where I understand that the data connected from one model to the other is aligned properly with consistent assumptions across all of them, so that when my system is experiencing a stimulus like a lightning strike, I can follow that traceability across all the model elements and see the impact. All right, so in summary, the DEIXWG's been very active. A number of different things have been ongoing over the last few years. Like I said, it started up originally back in 2017. I think it really got going in earnest in 2018. But looking at just the last few years, there's been a number of panel sessions at places like the IS or the IW. I've given briefs to SAE and to AIAA, to their Ascend conference. We've had a number of ongoing great collaboration with ISO. So Celia Sang at Dassault Systems is leading that product team, and they've been working to standardize a number of terms and create sort of a lexicon of standardized terms. We're also planning to have the DVM itself, as we start to mature it a little bit more and tie up a few ends on it, have that submitted as a standard reference framework as well through ISO. So that work is ongoing. There's also been work last year on expanding upon the user stories. We did that at the Incose IW, had some great sessions there, and even had an entire DEX track at the IS last year. And for all of our efforts over the last couple of years, I'm proud to say that the team did phenomenal. I'm so proud of them. And they, we got presented with the Achieving the Systems Engineering Vision Award for 2022 this past January in Torrance, California at the IW. And coming up next month at the NDIA SME conference, our own Ken Zhang will be presenting alongside Jack Lamb from NAVC on a presentation of NAVC's efforts. Jack works for NAVC to create a NAVC digital engineering framework that uses the DVM as a framework that it's built on top of. So very exciting stuff, and a lot of good activity that's going on. So again, if you guys can't notice, very proud of what they've been doing. And I think it's just amazing work that the team has been putting together. And with that, I know I'm a few minutes over my time. It's already after 8. I do apologize for the technical issues I had earlier. I'm glad I was able to get my computer to recover and send out my slides to my work computer. But if there's any questions, I know I see stuff in the chat here popping up, but I haven't looked at
Sean,
it.
if you, hey, thanks for doing this. There's probably a dozen or so questions in the chat. So if you can scroll through those and just address those, and we'll probably go to about 8:15 or so, and then we'll kind of formally end. And if people want to hang around, you can finish up with other questions. Does that sound good?
Yeah, sure.
Okay, go ahead and look through the chat.
Yeah. All right. So I'm going to start at the top and work my way down here. See a question here. It says, I guess William is asking, I would like to know your opinion of the trend of digital twin investments and implementations deployments with respect to digital engineering maturation as your touch points in your brief. Did you see a best practice emerge in industry teams and the quantification of uncertainty being visualized with the interactive 3D graphics of the simulations? Wow. Great question. So it's funny, I mentioned I come from a modeling and sim heritage at Northrop Grumman, and it's funny when I hear digital twin, and I know it's more than this, but my first thought for digital twin is high fidelity simulation, right? And I think the big difference is that it's a high fidelity simulation that's what we would have called, if we use the terms live, virtual, and constructive simulations, it's sort of what we would have called like a live simulation or a virtual simulation, where the entire simulation is not constructive, right? Where it's not all just a model running on a computer. It's maybe a hardware in the loop or a software in the loop type lab. And so when I see digital twin, that's, I guess, my background or my bias, that I kind of think of that. And so I think it's great that there's a lot of attention and interest in digital twins, but I kind of chuckle because I feel like, these are all things that, we've looked at, decades ago in terms of, having to, connect those things together. The big difference, though, is that, for digital twin, I think there's maybe a more crystallized use case in some ways in terms of using it for things like, health prognostics of a system, or trying to predict, hazards, or trying to understand, maintenance cycles and that kind of thing. So I think it's good, and I think there's some good maturation there. I think where it ties into the DVM work that the DEIXWG is doing is to be able to then, you know, help us to specify how we're federating those models together. I think, again, not that we haven't done this in the past, but it's just in the past, it would have been done with, rigorous amounts of paper and other documents that explain the H will or the S will, and how the various models and artifacts are connected together. And it would be a somewhat, I'll say, somewhat rigid kind of construction of that environment. It's single purpose driven for that particular use, as opposed to having a way of sort of provisioning the various models and being able to, federate them as needed, kind of thing, if that makes sense. All right, let's see, kind of working my way down here. Will DEX digital artifacts be at all relatable, i.e. Plugins, translator to pull NEM open?
This is Mark Adams. I wrote that. It's a little premature. You answered that question about 2 slides later. So,
okay, perfect. Thank you. Thank you.
Okay, so the answer is yes.
Yes, absolutely.
Great briefing
absolutely.
too, by the way. Thank you.
Oh, thank you. Appreciate that. All right. William is asking, and again, thank you, Mark. If anybody, if I look at your question and I start to read it and you're like, oh, that's OBE, feel free to jump in and let me know. I'm kind of just reading them as I see them here, so apologize. So William is asking, 16 years ago, the OSD tasked USUHS to focus on the warfighter as a weapon system. Yep. Arguably the origin of human digital twinning. Yep. In fact, actually, my colleagues from Northrop Grumman and APL who worked in human factors, they were always very much in favor of, the human needs to be part of the equation, not just an afterthought, right? Using systems thinking to recommend how to optimize warfighter performance. What is your opinion of the maturity of industries delivering defense sector goods and services in terms of warfighter models as nuanced as material models? Yeah, boy, that's a great question. So again, back to my comment about my friends in human factors engineering or human systems integration, I'll say, a quick anecdote was, working on a program for NAVAIR a while back, major ACAT-1 program for PMA 234. One of the things we were looking at was a jamming system on the wing of an airplane, and the performance of the pod, performance of the aircraft platform, and the performance of the pilot or the electronic warfare officer. And how do we, sort of budget the amount of time or responsivity or whatever it is you want to call it, latency, that we were giving to each of those 3 things. And my friend Maggie, the human factors person, her big concern was, I don't think we're looking at the human, right? I think we're just, contractors working on the jammer. The government has, the contractor who's working on the aircraft, and we're more worried about, the performance that we can squeeze out of the jammer and the aircraft, but we're not really thinking about what that means, for the electronic warfare officer. So are we going to wind up with a situation where we kind of, tell the pilot or the EWO, yeah, when you need to make that jamming assignment, you have exactly 1 millisecond to figure out what to do. So good luck with that. Obviously we can't do that, right? So her point was, the human, to an extent, is really the thing we can't redesign, right? We can try to, bolster the person's skills. We can try to, come up with a different way through ergonomics or whatever to make them more efficient at what they do. But there's just only so much that a human brain can do, right? So we have to take that into account and almost treat them as a design constraint as we then work the rest of it. So being able to have warfighter, models delivered in much the same way as you deliver material models. That's one of the things that they were doing. So they'd have workflow models in a tool called Imprint that would handle all the workload and all that kind of stuff based on, you know, tactile audio inputs, visual inputs, whatever it is. And they try to assess, you know, the workload on the warfighter, and were they going to be, you know, overloaded, overtasked, that kind of thing. And so we would use that Imprint model as, first of all, it was a deliverable, but we'd also use the model to help guide the rest of the material decisions for the rest of the you know, the aircraft and the jammer and that kind of thing. All right, great questions. Gosh, you guys are awesome. All right, so what is the relationship between digital threads and the digital artifacts? Great question from Dave on here. So yeah, you know, so the digital artifacts, you know, a digital artifact, let's take an example. A digital artifact could be a SysML model. The digital information contained in that digital artifact might be the data about your system as captured in that SysML model. And it may be captured in the form of, you know, blocks and activities and, you know, various relationships between the elements, that kind of thing, right? A thread, digital thread, would be then a purposeful sort of intent-driven or goal-driven thread that you pull through that SysML model, and probably ideally more than just the SysML model. You know, the idea of a digital thread goes back to the Lockheed coined term of digital tapestry, where, you know, you have this tapestry or what we would now call a digital engineering ecosystem of various models across, you know, various tools. In a SysML model, you could still pull a thread through it. We would just probably say, hey, it's just traceability, right? I need to know, for all my requirements, have they all been satisfied? That's a very simple digital thread. It's trivial, right? But it's an important one. And that could be a digital thread if, say, the requirements are in doors and my architecture elements are in Cameo. And now let's throw in another thread. I have to, you know, trace down to, you know, mechanical models that trace to the configuration items in my SysML model. So now I have SysML CAD model requirements at system level. Maybe I have mechanical requirements managed indoors too, or somewhere else, you know, maybe in my PLM tool. So pretty soon the digital thread starts to balloon out. But the idea is you're still pulling that single digital thread through your digital tapestry, and you're doing it because you want a particular answer. You're looking for a particular thread of information that you need to assess. So that's kind of my idea behind what that relationship is.
Hey, Sean, we're for sake of time, we're getting almost wrapped. How about pick one more to wrap up with a simple
Okay.
answer, and then we'll wrap up.
All right. Let's see. So I see one of the questions, can we use DVM as the basis of a DE ontology? So we actually have it sort of the opposite. I'll say that the ontology, we have an ontology that we're constructing right now to act as a underpinning for the digital viewpoint model framework. So the DVM is the framework, sort of like UAF, and the ontology that we're developing would be similar to how the ideas ontology is used as the underpinning of UAF. So we're working on that ontology now, and that will, you know, provide some much needed rigor underneath the DVM. But I wouldn't use the DVM as the basis of an ontology. It's actually built on an ontology itself, not sort of the, you know, that idea. But that being said, the whole idea behind the DVM is to act as sort of a conceptual reference framework. So in some ways, it's sort of similar to the idea of an ontology, but it's more like the framework concept from UAF. And I'm sorry I didn't have enough time to get to the rest of everybody's questions here, but if you have any questions, other things that you want to ask me about, please feel free to reach out and contact me. I think my email address is somewhere on the you know, on the Eventbrite page or wherever it is, or just get in contact with the Incose chapter. They'll be able to get a hold of me. Obviously, I'm the president-elect this year, so you guys aren't getting rid of me. But just, you know, let me know, and appreciate it. Thank you so much for your time and attention. Means a lot to me.
All right. Thanks, Sean. Thanks for your presentation. Thanks for hanging around and coming back and after you had a snafu and answering all
Oh,
those
gosh.
questions. Yeah. And I guess if people want to hang around afterwards, they certainly can. And hey, board, do we still give out those virtual mugs or anything? I don't remember how if we still do that.
No,
but-
we don't have a door, so we don't do door prizes anymore.
and the speaker mugs or anything like that anymore. Okay.
Yeah. Yeah. Okay.
All right. Sorry about that, Sean. You
No,
get a
it's
virtual
No,
one.
it's all good. It's all
Yeah.
good.
But unless you have anything else, this concludes the presentation for tonight. Thank you everybody out in cyberspace. And I guess, guys, if people want to hang around for a few minutes, the space will be open. See ya.
Thanks a lot, everybody.